Okay, today we're going to talk about systems of word problems with linear equations. Before we talk about that, take a moment, pause the video, and check last night's homework. Alright, there are three types of systems we're going to write equations for. The first type is what I like to call a total problem because it somehow involves the word total. The second type is a shopping problem because, like it sounds, it involves shopping or the purchasing of some kind of object. The third type is just the old-fashioned problem where we're just going to use math vocabulary to write our equations. There are 4 steps we're going to follow every time we have a word problem involving systems. First, we're going to define our variables. I'm always going to use x and y. You can use whatever you want. Then we're going to write our equations. We're going to solve. And then we're going to check and write the phrase. We always want to make sure that our answer makes sense within the context of the problem. Okay, so the first type of problem we're going to do is a total problem. The Drama Club sells 475 tickets to the talent show. Student tickets cost $3 and adult tickets cost $5. They make a total of $1,673. So the first thing we need to do is define our variables. Well, we're going to let x equal the number of student tickets sold. And we're going to let y equal the number of adult tickets sold. If you're having problems, you can always look at the question that's being asked. At the bottom, it does say how many adult tickets were sold, how many student tickets were sold, and that can guide you in defining your variables. We need to write a system of equations to represent the situation. Now, it's not the word total at the money. This total, it's not this word that tells us it's a total problem. That's just telling you how much money they made. What tells you that it's a total problem is that they sold 475 tickets. They sold 475 tickets total. They tell you that they sold 475 tickets total, and that's all the information you're given about how many tickets they sold. You want to be on the lookout for these pieces of information where they give you a number, and it ends up really just to be the two unknowns added together. Because 475 is the two unknowns added together, one of our equations is going to just be x plus y equals 475, because if I add together the number of student tickets sold and the number of adult tickets sold, I get 475. The other equation is going to come from all these numbers involving money. One thing I always like to tell you is you never want to involve numbers that have a dollar sign in front of them and numbers that don't most of the time. Student tickets cost $3, so we're going to start with 3x plus adult tickets cost $5, 5y, and from $3 a student ticket and $5 an adult ticket, we made $1,673 total. The best way to solve this system is with elimination because everything's lined up nicely. I'm going to eliminate the x's by multiplying the first equation by -3. And that's going to give me -3x minus 3y equals negative 1,425. Now I'm going to write the second equation right below it. I'm going to add down and I get 2y equals 248. Divide by 2. And we get y equals 124, and that is adult tickets sold. Okay, so obviously if we sold 124 adult tickets, all we have to do is go back up here, and we would know that x plus 124 has to equal 475. We're going to subtract 124 and we find out that 351 student tickets were sold. If we wanted to check that, we could do 3 times 351 plus 5 times 124, and that would give us the total amount of money earned, $1,673. So that's a total problem. And remember, it's not the word total here that tells us it's a total problem. It's because one of the numbers we're given is equal to the total of both variables. Okay, it's that x plus y equals the total, which is why I like to call this a total problem. All right, the second type of problem is probably the easiest kind for kids, and those are the shopping problems. And this isn't actually a shopping problem, but I like to call it a shopping problem because there were 2 situations. This is the only really situation where you're going to use money and non-money numbers together. The soccer team is having a fundraiser. They sell 5 calendars and 4 boxes of cookies for $50.15. They also sold 3 calendars and 7 boxes of cookies for $48.95. Well, obviously, we look down here and we see it says, how much does each item cost? So X is going to be the cost of 1 calendar, and Y is going to be the cost of 1 box of cookies. So our system of equations, 5 calendars and 4 boxes of cookies, is going to become 5x plus 4y equals 15. And then 3 calendars and 7 boxes of cookies is going to become 3x plus 7y equals 48.95. Okay, so again, we're going to use elimination, and we have to multiply both equations in this situation. I'm going to eliminate the x's. It really doesn't matter what you choose. I'm going to multiply the first equation by 3 and the second equation by -5. Okay, so when I do that, I'm going to end up with 15x plus 12y equals $250.75. And the second one's going to be -15x minus 35y equals -$244.75. Okay, so I just realized I made an arithmetic mistake. I was thinking there, wait a second, something is not working out right. That's a mistake. You probably already caught it. And that should be $150.45. Okay, so now we're going to add down, and 12 minus 35 is -23y, and 150.45 minus 244.75 is -94.3. We're going to divide each of these by -23. And we find out that y is 4.1. But I'm really going to write that as $4.10 because that's going to be the cost of 1 box of cookies. Okay, so if $4.10 is the cost of 1 box of cookies, we need to find out the cost of a calendar. So it doesn't really matter which equation we use. I'm just going to use this first one. And we have 5x plus 4 times 4.1 equals 15. And 4 times 4.1 is 16.4. And subtract 16.4. And we get 5x equals 33.75. And we end up with the cost of 1 box of 1 calendar being $6.75. That's how I spell calendar. And so that is how you complete a problem that gives you two kind of shopping situations. The last problem we're going to look at is one that's just a traditional, old school systems problem where we're just going to use the math words in the problem to write our equations. Sam is 3 years older than twice his sister's age. The difference between their ages is 10. How old are Sam and his sister? Well, of course, the first thing we want to do is we're going to just let x equal Sam's age. We're going to let y equal his sister's age. All right. Whenever we see the word is, we want to remember that that's going to be equals. So Sam is, so x equals 3 years older than twice the sister's age. The difference, remember the word difference is the answer from subtraction, between their ages is 10. Now we know that Sam is older than his sister, so he's going to come first. X minus y equals 10. This problem is set up really nicely for substitution. So we're just going to substitute, and it's going to be 3 plus 2y minus y equals 10. 3 plus y equals 10. And we find out that Sam's sister is 7. Now to find out Sam's age, I'm just going to take my 7 and put it back into this equation. So x minus 7 equals 10. We find out that Sam is 17. Okay, so right now I would like you to please get out your homework for tonight, which is the Using Systems to Solve Word Problems worksheet in your packet. There are 10 problems. It's a front and back worksheet, and please get started.